Okay, now this one is an improper integral, as you can see, because of the infinity. Let's first calculate the indefinite integral using tabular. Plus minus d integral x goes here, e to the x goes here, x differentiates to 1, 1 differentiates to 0, e to the x integrates to e to the x, integral of e to the x is again e to the x, plus minus plus, go this way, and that gives you the integral of x e to the x minus e to the x plus c. But you also have to know how to handle this negative infinity. So what do you do when you have an infinity?
Replace it with a letter?
You have to replace it by a letter. So you rewrite it to be an integral to be a to 0, x e to the x dx, and then say limit of a going to negative infinity. Now we already know the antiderivative, it's calculated there, so the integral that you have is x e to the x minus e to the x. You don't need plus c for definite integrals, so that's all we need. And then you put a and then 0. If we plug in 0, this will be 0. If we plug in 0 here, it will be
1.
Yeah, just negative 1. And now let's plug in a. It will be a times e to the a minus e to the a. And we're sending limit a going to negative infinity. Now,
plus e to the a.
Oh, thank you. It's plus e. Because you're subtracting this entire thing. Thank you. Yeah, so when you subtract, it's a good idea to always to put parentheses, because that's a major source of mistake. Now, what is e to the negative infinity? Can somebody tell me?
Negative. Oh, no,
No.
0.
It is 0. It is 0 because it's 1 over e to the infinity, which is 1 over infinity, which is 0.
What if it was positive?
What would that be? What would this be? I just said it's infinity, right? E is like 2.7.
We wrote it below that because it's negative infinity.
E to the positive infinity is like E is 2.7. So if you multiply 2.7 over and over again, you get really, really big number. So this will be infinity.
Oh, okay, yeah.
Yeah.
So,
Now,
sorry.
what?
What do we do when we have that node? We have that.
So
right
that goes to 0. That's good.
there. No.
Okay. This is the part that we don't know. The problem here is that this is not so clear. A is going to negative infinity, whereas e to the negative infinity is going to 0. What's 0 times infinity?
0 is 0.
0 times infinity is?
0.
No, 0 times infinity is indeterminate.
Oh.
We don't know. Sometimes 0 times infinity is 0, sometimes 0 times infinity is infinity. You don't get it?
How the hell
So that
is
everything that's times 0 equals 0.
What's this limit when x is sent to infinity?
Infinity.
What's this limit when x is sent to infinity?
1
0.
over infinity.
1 over infinity, which is 0, right? What's the actual limit?
0.
No.
Well, if it's infinity over infinity.
No. What's, okay.
Oh. I see what you're saying.
This is x squared over x plus 1, right?
Yeah.
What's that?
Infinity over infinity.
Yeah. So let's use L'Hopital's. What's this limit?
Infinity.
Infinity. 2 times infinity over 1. So infinity times 0 is?
Infinity.
Infinity
Sometimes
for this example.
Sometimes infinity. Sometimes
What if I had x here and x squared there? Then it's a totally different answer. It will be 0 in that case. What if I had x squared both cases? It will be 1. So what does that tell us about infinity times 0?
You don't know what it is.
You don't know what it is. What is that called?
Not determinate.
Indeterminate.
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 Does not converge.
No, it's different than does not converge. Don't confuse things, okay? It means indeterminate. Indeterminate means indeterminate. What does it mean? You can't determine
It means
it.
you have to do more work.
Does not exist means we know that the limit does not exist. That's a piece of knowledge. Here, it means we don't know. There's a difference. Okay?
I think he was joking.
All right. Okay, so I got too worked up on a
No, it's
joke.
okay. You needed to get it out. It's okay.
Yeah.
Just let it out. You can vent on us.
Yeah, we were joking.
All right.
We can take it.
Okay. So, we have infinity times 0, which means we don't know. We have to do something. So let's try something. What is that something? Well, see, the greatest tool available to us is the L'Hopital's. Okay? It makes
Sure.
everything so easy. But it's not a fraction, so what do we do?
Make it a fraction.
We make it a fraction. How?
Raise it to ln.
No,
Or
no.
Make it,
Just
no?
make the denominator and numerator the same.
Ah,
That.
Right? See, negative power makes it a reciprocal, right? So if you divide by e to the negative a, that's same as multiplying by e to the a. Yes?
so what about the other terms in that -1 and the e to the
Oh, we
a?
already know that this is -1 and then this is 0. E to the negative infinity is 0.
So you can pull that term out and evaluate.
So this is like -1 plus limit a going to negative.
Ah, okay.
Yes?
That would be also 0.
This one?
Yeah.
Well, first of all, if you plug in negative infinity here, that's e to the positive infinity, so this is infinity over infinity type.
So you're at the derivative.
Now you can use L'Hopital's. That allows us to use L'Hopital's. If we use the L'Hopital's, it will be limit a going to negative infinity of 1 over e to the, negative e to the negative a. Okay. And now you plug in negative infinity, so it will be 1 over negative
e
infinity. But what is 1 over negative infinity?
0.
0. So this will be just -1 plus 0.
plus e to the negative infinity, which you said was 0, right?
What did you say?
Because you have the
Oh,
1 more
another-
plus e to the a at the end.
Oh, this one is 0. E to
That's
the
0,
negative
right, yeah.
infinity is 0.
That's
So
right,
it's
okay.
-1 plus 0 plus 0.
Plus
so
0, yeah, okay.
It's -1.
Cool.
I have one question.
Yes.
How are we just able to shove the e to the a down there and make negative a? Oh, we don't. Never mind.
Well, it's like to divide by a fraction. Here's a tip. So if you have this division, right? If you divide by a fraction, keep, change, flip. Right? But what is this? 1 over e to the a is e to the negative a. Right?
Yeah.
Okay?
I realize it as a question asked.
All right.
They're like equal.
Oh,
Yes.
I have one more. I hope this isn't a dumb question. But,
What?
so say that the other two terms in that statement were a bit more complex and did not evaluate to something simple like -1 or 0. Could you say that the limit of the first term minus the limit of the second term plus the limit of the third term is equal to the limit of all three of those terms together?
That's what he did. Didn't we?
Yeah.
No, that,
So it's a property of limits. If you have individual limits that are finite, then you can evaluate the limits separately, and then the sum of all the limits is what you get. On the other hand, if you have like infinity and then another one has negative infinity, then you don't know.
Okay.
Yeah, because infinity minus infinity is another indeterminate form.
Okay.
Who made you the schedule? How much of a
I always have to stop for a minute when there's a minus. You want to ask, wait, isn't that function positive? Why is this giving me minus? And if you actually drew the graph, here's how the graph looks like. If you plug in 0, you get 0, right? If you plug in -1, that's -1 times e to the -1. E to the -1 power is positive times negative, it's negative. So actually at -1 it gives you a small negative value. And then eventually when x goes to negative infinity, that's like this part right here. It goes to 0, we just proved it. So we know that it will go down like that and go close to 0. On the other hand, when x becomes big, like e to the 10th power, that's already a very big number, right? So on the right side, it goes like that. So that's the graph of y equals to x times e to the x. And of course, if you integrate from negative infinity to 0, it is below the x-axis, so -1 does make sense. So you want to do this kind of check just to make sure that what you're getting is not strange. You have a question?
No, because I was about to say, like, why did you put positive exponents, but you're just using it to complete the graph?
Yeah, I just wanted to know the graph. Yeah, you're right. We don't have to draw this right side if we just want this.
I have a quick question.
Yes.
So I understand what we did, like that one, but it's -1 minus a, but you have it -1 plus.
Oh,
That's what's confusing me.
sorry.
Um,
I knew in my mind that's 0. That's why I changed the sign. But that you're right. That it should have been minus. So this should really have been a minus. Okay, let's look at the second question. This second question doesn't look like a improper integral, but it is. Why?
Because it's going from -1 to 2, so you got to break it up from -1 to 1, and then add up to 1 to 2.
Why do you do that?
It's a parabolas.
Huh?
Because you can't have it go through 0. Or
No.
You can't have it go through
I forget
1.
the-
Why?
Because of the
It's undefined at 1. If you plug in 1 into this function, you get infinity.
Yeah.
Yes?
Don't you separate it out from like?
Yeah,
two-
that's what he was suggesting,
Yeah.
and you have to explain why. Why do you separate it?
I forget the reason why.
Yeah, you have to remember like an
You
absolute
guys
or something.
replace it with like a variable. You replace it with a.
Yeah?
That's an asymptote right
You have
there.
to find it from, you have to find it from the left of 1 and the
Here's
right
the
of
graph. Here's the graph. If you plug in something close to 1, say 1.1, 1.1 minus 1 would be 0.1. 0.1 squared would be 0.01. 1 divided by 0.01 is
Big.
100. It's a big number. So what happens near 1 is that the graph is really big. Same thing if you plug in 0.9. They both give you something really big. And then it goes towards the 0. It's always positive, but when you plug in huge negative values or huge values, you end up something close to 0. So
What do they always come into this room?
you get, here's -1, here's +2, and you're trying to find the area here.
So you have to break it up.
And once you see the graph, it naturally suggests that you have to break this up because we don't know what's happening here. You have to break it up at 1. So this really should be thought as the integral from -1 to a of 1 over x minus 1 squared,
Because it's 3%.
and then from b to 2, where this left side a, so what you have is like you have a small number a before 1, and you have a number slightly bigger than b after 1, and you just close in this unknown region that you're not so sure about, right? So that this gap will be eventually filled in, and you end up with the entire integral. Okay. So a goes towards the 1 from the negative side, and then the limit plus the limit b goes to 1 from the right side of 1 over x minus 1 squared dx. Okay, so integral of 1 over x minus 1 squared is x minus 1 to the negative 2 power. And then you have to use the power rule, so you add 1 to negative 2, giving you negative 1, and you put the reciprocal in front, which is negative, and then plus c. That suggests that we need to do limit a going to 1 minus of negative 1 over x minus 1. Negative 1 power means it's 1 over, so I'm just rewriting this result as negative 1 over x minus 1. That's the integral. And we're plugging in a and negative 1 plus limit b going to 1 plus negative 1 over x minus 1. And you plug in 2 and then b. Okay, let's continue. When a is plugged in, it's minus 1 over a minus 1. When negative 1 is plugged in, that's negative 2, but there's a minus, so it's positive 1/2, but you're subtracting a 1/2. You take limit a going to 1 minus, plus limit b going to 1 plus. When 2 is plugged in, that's negative 1, minus negative 1 over b minus 1. Okay, let's further investigate. This is, if it's 1 minus, what is 1 minus minus 1?
It's really small.
It's small, positive or negative?
But it's coming from the right side, left side, so it's
1 minus means it's slightly less than 1, right? 0.9999. If you subtract 1, is that positive or negative?
Negative.
So it's a 0 minus. Okay. So if you plug in 1 minus and you subtract 1, that's 0 minus. So you have negative 1 over 0 minus, minus 1/2, and then minus 1, plus 1 over 1 plus minus 0. What's that? 1 plus minus 1.
positive 0.
It'll be 0 plus. It'll be positive 0. Now what is 1 divided by 0 plus?
Infinity, positive.
Positive infinity. What's 1 divided by 0 minus?
Negative, but it's
Negative infinity, but there's a minus, so it's a positive infinity. So you have positive infinity minus, if you combine these, it's minus 3 over 2, plus another positive infinity. What's that?
pretty much infinity.
Infinity.
It's infinity. Okay? If you add infinities, it must be infinity. Yeah. So that's the answer. What if you forgot to do that? What goes wrong if you didn't do what I just explained?
If you just like integrated it,
Yeah, if you just didn't know that this is an indefinite integral, and if you just integrated
You get the
this,
same answer, but
you don't get the same
No,
answer.
you get
No.
positive 3 over 2. You did it.
No, you get negative 3 over 2.
Or, oh.
So
Well, you get some number.
you find the antiderivative and you plug in 2 and negative 1. The result is that when 2 is plugged in, you get negative 1. When you plug in negative 1, you get positive 1/2 when you're subtracting. So you get negative 3 over 2. Now suppose you did that on the exam. What should immediately raise a flag?
it's
That this is a negative value for
squared.
something that's squared, that's a positive function, right? Can you have a negative area when you're integrating a
Oh,
positive
okay.
function? No way. Okay? So you should know right away that this answer would be wrong, and indeed it's wrong.
Also, it's only like 3 lines of work, there's no way.
Yeah, so there'll be like another
Yeah.
indirect way of knowing.